Okay, for these, again, we have some of the pieces of the equation do not have logarithmic expressions with them. But this time, I've got two log expressions on the left side of the equation being added together, and on the right, just a plain number. So the first thing I would need to do is condense the left side here. So log of x plus log of x plus 3, I could condense that using product property. That would be log of x times x plus 3. And then from there, I would need to change it to its exponential form in order to continue solving, since there is no log on the right-hand side of this. So this time I do need the base of this logarithm, and like we talked about yesterday, since there is no base written, we know that that means that the base is 10. It's a common log. So when I rewrite this in exponential form, I would say 10 to the power 1 is equal to then the argument there. I'm going to go ahead and multiply those together while I'm at it. So that would be x squared plus 3x. Now what I've developed here is a quadratic equation. So to solve quadratic equations, our strategy is usually to create a zero on one side of the equation and then try factoring. And if factoring doesn't work, of course, we have some other things in our bag that we could try, like quadratic formula or complete the square. But this one will factor. So we'll go ahead and use that strategy. The things that'll multiply to make a negative 10 and add to make a positive 3 would be a positive 5 and a negative 2. Then he said each of those factors equal to 0 and solve, and we get negative 5 and positive 2. Okay, once again, we do need to check our answers to make sure that they don't violate the domain of the logarithms there. So whatever x is, when you put it in, it has to make sure that the arguments of your logarithms are still positive. So if I take negative 5 and I put it in place of x here, that would say log of negative 5, which is undefined. So that one is not a good answer. I have to exclude it. Then I'll try x equals 2. If I put in 2 here in this first one, that's still okay. If I put 2 in for x in the second one, 2 plus 3 is still positive, so it works for both of them. So this one actually has only one answer, just x equals 2. Let's try one more like that. So over here on the right, again, on the left side of the equation, I've got a log plus a log, and on the right side, I've just got a plain number, no logarithm involved. So my first step would be to condense the left side of it. And I'll do that using the product property. So that would be 2x times 4x plus 3. Now, because I've got a logarithm on the left and just a plain number on the right, the strategy to solve now would be to change it to its exponential form. So the base of the exponential would be 3. The power is across the equal sign, so squared, equals the argument of the logarithm. And once again, I'm going to go ahead and distribute that 2x in there. So that would give me 8x squared plus 6x. And now I'm down to a quadratic equation. So to solve it, I'm going to create a 0 on one side. And then we'll try factoring. All right, so let's see. My outside and my inside product would be 72, negative 72 on this one. So I'm looking for things that'll multiply to make a negative 72 and add to make a positive 6. And that would be a 12 and a negative 6. So I know it's factorable. I'll go ahead and set up my parentheses. In order to get an 8, I could use 1 times 8 or 2 times 4. If I do 1 times 8, I'm not going to be able to get my outside and my inside products that I need there. So I'm going to use 2 and 4. So 4x and 2x. Then I'll say 4 times whatever I put over here has to be either positive 12 or negative 6. I can make the positive 12 multiplying by a positive 3. And then 2 times whatever I put over here has to be negative 6. So that would be a minus 3. So now it's factored. To solve now, I'll set each of those factors equal to 0. and then solve those little equations there. We can do that in our heads now. So 3/4 for one of them and -3/2 for the other. And then once again, we do need to check and make sure that both of these answers are good answers for this problem. If we have to discard both of them, then we would say that there is no solution. So if I take 3/4 and I put it in place of x here, that's 2 times a positive number, so that's still going to be positive. And if I put 3/4 over here, I'd have 4 times a positive number, which is positive. And then if I add to that, that's still going to be positive. So that one works for both of them. So this one's good. -3/2, on the other hand, if I put it in place of this x in the first logarithm, I'd have a positive times a negative, which makes it negative. So right away I could discard that one. So my only solution on this one would be 3/4. Alrighty, now you've got a couple problems similar to that one to try.